Hello everyone and welcome to a new tutorial where we are gonna create a sphere and then put a Voronoi pattern in it, and after that we're gonna create circles depending on the size of each cell. We will be able to change the number of subdivisions of the Voronoi, and that will change the shape of our ball, or the distribution of the circles, and we will also be able to adjust the size of each of those circles. I hope you enjoyed, and leave a comment if you like it. So the first thing that we are going to do is create our surface. It can be any kind of surface. I'm going to create a sphere, and I'm going to do it in Grasshopper. So let's double click on our canvas and get a sphere. And the radius of that, for the radius of that sphere, I'm going to create a slider, let's say maybe 200. Okay, that should be okay. And then we are going to create the Voronoi. So to create the Voronoi, we have done it previously. I'm going to double click and type Voronoi, and I'm going to get the Voronoi 3D. Okay, so the Voronoi 3D, what asks us, it's a bounding box and then points, so it can create the cells. So I'm going to populate that sphere with randomly located points with this item right here, component, which is called populate geometry. So I'm going to get that geometry and populate it. I can change the position of those points by changing the number of the input, and then I can change the amount of points by changing the amount in the n input. Okay, so I'm going to create a slider to control that of maybe 150 and connect it to the n, so I can change the amount of points on this geometry. So next thing that I'm going to do is, if I connect this here, okay, I'll get a Voronoi. Okay, the thing is that it is creating a box, automatically a box bounding the points, but not the sphere. So what could happen, as you can see here, the sphere is, I'm going to select it so you can see it properly, is this green circle that it's coming out of that cube, of that bounding box, and we don't want that, because that's going to give us trouble when we try to find the intersection between those cells and the sphere, which is what we are going to try to find, because on that spot it is not being intersected. So what we are going to do is create our own bounding box, okay, on the sphere. And as you can see, I'm gonna turn this off for now, and that is gathering everything, but it's gathering everything right on the limit. Okay, so I wanna, to avoid any trouble, I'm gonna make this bounding box a little bit bigger. So I'm gonna scale it. Okay, I'm gonna make a uniform scale, and the center of that scale, if I connect this here, the center of that scale is the origin. Okay, you can see it here, but I'm going to make sure it's the center of that box. So I'm going to get the volume component, which gives us not only the volume of a component, but also the center, the centroid. So I'm going to connect it here, and that way I make sure it's always going to be, if I move that sphere, this is going to stick around. And for the factor of the scale, I said I need it to be slightly bigger. So I'm going to create a slider of 1.1, for example, and I'm going to connect it here. And that way it's slightly bigger than the sphere. So I'm playing safe, let's say. And that geometry is the one I'm going to connect here on the bounding box of the Voronoi. I'm going to turn this off. And if we turn this on, we can see the Voronoi, and we are making sure that all the cells of this Voronoi are intersecting our sphere. So to find those intersections, I'm going to go to the component called brep. It's right here, and what this does, it just finds us the intersection of two objects. Okay, so I'm going to connect this here. This I'm going to turn it off. This I'm going to turn it off, and this sphere as well. And as you can see, we already have those cells where we are going to create our circles. Okay, So to create these circles, okay, I'm gonna go get the circle component, and we are gonna create the circles, and then we are gonna trim our initial surface with those circles. Okay, so those circles need to be on our surface. They need to be right on our surface, otherwise they won't cut it, they won't trim it off. So the next thing that I need to do to create a circle is create a plane. Okay, so I need to create planes in each of those cells of our brep. So to do that, I'm gonna get the normal plane component, which what it does, it creates a normal plane to a surface that I'm gonna give it to it. That surface, okay, those surfaces, I'm gonna get them from each of these cells. So I'm gonna create surface with the patch component. So I'm gonna get the patch component, and I'm gonna get flat surfaces on each of those cells. Okay, once that is done, I'm gonna turn this off, and those are flat surfaces. Okay, now to create these planes, I need those planes to be in the center of each of those little surfaces. So to do that, I'm gonna get the area component, which is similar to the volume component that we used previously, but the area component gives us the area of a surface and also the center. Okay, so I'm gonna connect the center right here, and I'm gonna turn this off. And you can see those planes, okay, they are being located on each of those centers, but they are parallel, or they are being guided off by the universal X and Y axis. So what we need to do is we need to get the normal vector of each of those surfaces. For that, we have a component called brep closest point. Okay, so if we give it a point, which is going to be these centers, we already have them, and we give each of these breps, we will get many things. Well, many things, no, 3 outputs. So the position of each of those points, the normal vector, and the distance of those points to our brep. So actually this is to measure a distance or calculate what's the closest point of a brep to a point. But now what we need is the normal vector. So I'm going to connect it here. And now you will see they are sitting on each of those surfaces, which is exactly what we wanted. I'm going to turn this off, and those are the planes where we want to locate our circles. So there you can see our circles. They're pretty small, okay, because the default radius that we have on the circle component is 1, okay. But what we want to do is create or make the circles very similar or dependent on the size of each of those surfaces. Okay, so what we need to do is calculate the area of each of those surfaces, which we are already doing with the area component, and we need to go to the formula of the area of the circle. So basically the expression that we need is, we all know the area of a circle is going to be pi, sorry about the letters, multiplied by the radius with a square power. Okay, so basically we need to get, I don't know how to say it in English, but we need to get everything to the other side of our formula but the r. So what we need to do is divide those areas by pi, and also get the square root of that result, and that will give us the radius that we need. So first thing that we're going to do is we're going to get a division. I'm going to get the slash, and then I'm going to write straight ahead 3.14, which is the value of pi, which is the, I'm not going to use more decimals, and that's what we are going to divide the area of. And that value, okay, we are going to get the square root. So I'm going to go to maths, and here we have the square root. So if we connect this here, we will get the square root of that value. And then if I connect this here, I'll get more or less the size of, I'm going to turn this off, and we have those circles. The thing is that, well, we are adapting the area of surfaces to our circles, but some of them they overpass the boundings that we want. So we are not going to get too complicated on this. So what I'm going to do is I'm just going to divide that value. Okay, so I'm gonna get a division component. Okay, and those values I'm gonna divide them by a number which is gonna be bigger than 1. So I'm gonna get a something between 1 and 2, because I don't even want to get to half of the size of each of them. So I'm going to connect this here, and then that result I'm going to connect it here. And if I make this bigger, okay, then I start getting more or less the shape that we're looking for. In some spots we still have trouble, so I'm just going to go safer and make it bigger. Okay, I'm not going to get too much into that. We could do it some other way, but I'm just going to leave it as it is. So now that we have our circles, we just need to trim our surface. But to trim our surface, I'm gonna those circles are flat on each of those planes, so I need to pull them. Sorry, not pull point. I need to pull them towards the surface. So I'm gonna get the pull curve component, which what it does, it just pulls a curve into a surface. And that way we can make sure that we trim it properly. Okay. Now that you can see both of the components, you can see that the circles, which are some of them are sitting on the surface of our sphere, but some of them are not, because our circles are flat curves, and a sphere is obviously not a flat surface. So that's why we are doing this step. Okay, so that being done, we use this surface split component, which is right here. And the curves that I need are these. And actually I'm going to flatten this. And the surface is this one. So this gives us all the surfaces, the small surfaces, and also the main surface of our sphere. So what I'm going to do is I'm going to measure, because I only need the big or the main sphere surface. So if I measure each of those surfaces, both the circles and the sphere, if I find out what their area is, okay, and I sort that list, then I can stick to the bigger one, to the biggest one. Okay, so basically I'm gonna connect my surfaces here and my areas here. So what this will do, turn this off. What this will do, if I put or if I get a panel, okay, I have all those areas, and now they are organized from the smallest area to the biggest one. And you can see that the last one is much bigger, it's way bigger than the previous one. So the last one represents my the main area that I need. On the other output is where I get my surfaces. They are all trim surfaces, but I know the one that I need is 182, okay, because it's the one that has this value. So what I'll do is get my list item component, and I'm gonna reverse by right-clicking and reversing that list. Then I get my first item is gonna be the biggest one, okay, and there we have it. Okay, last thing that we could do is I usually like to if I want to give or add thickness to our geometry, I like using the Weaverbird plugin. So for that, Weaverbird works with meshes. So for that, I'm gonna make this a mesh. And then if I go to Weaverbird, here I have the Weaverbird's mesh thicken. If I connect it here, we have our mesh. You can see the polygons on our mesh. If we want to get more polygons to have a more organic shape, then we have another component on Weaverbird as well, which is called Weaverbird Catmull-Clark's subdivision. So what it does, it just subdivides each of these faces of this mesh and makes it even smoother. Okay, actually we can do this way, or we can do that way. and we have a proper mesh that we can send to the 3D printer and make this kind of sphere. We can always go back and change the size of the sphere, the number of the points of our Voronoi that will make smaller or bigger circles, and we can obviously change the size of those circles with this. Okay, I hope you enjoyed it, and see you next time.